Hi guys, welcome to NLP lecture 6. So today we'll be covering a important topic that's essentially what is the difference between generative and discriminant classifier, and I would be reading a text from the book. So guys, what is the book trying to say? The most important difference between naive bias and logistic regression is. So guys, have we seen naive bias or not? Right, we have seen naive bias, and as I said that there are other classification techniques as well. Some people use logistic regression also, but guys, as I said, now no one would use logistic regression in an NLP based task. Okay, those were old days, but it's good to know these things. But the main context over here is what is the difference between generative and discriminant classifier is that logistic regression. So you can just consider logistic regression as a discriminant classifier, is a discriminant classifier, while naive bias is a generative. Okay, that's very funny, but yeah, that's how they have framed it. But let's try to go in depth of what they are saying. They are two very different framework of how a machine learning model is built, I think. Yes, so see guys, thing is, whenever there is a machine learning model, essentially either it can be discriminant or it can be generative. So essentially what are generative models is that today you'll be seeing LLMs, right? So you have heard about GPTs, you have heard about BERT. Even if you haven't heard about BERT, it's okay. You have heard about Gemini, you have heard about Llama series of models. All these guys are what? These are generative models. Obviously, one could argue that these are generative models since they have the ability to generate new content, which is true. This definition is correct, but let's try to move ahead and try to understand what are they trying to say. So just try to understand it by this difference. Consider a visual metaphor. Imagine we were trying to distinguish dog images from cat images. Okay. So you're trying to create a classifier which will distinguish dog images and cat images. A generative model would have the goal of understanding what dogs look like and what cats look like. Understand? You might literally ask such a system to generate, that is, draw a dog. Come back. So it's saying that whenever we have a generative model, the goal is to understand how does a dog look and how does a cat look. And essentially, as I said, that it has the ability to generate new content. So guys, DALI is there, image gen is there. These are basically text to image models. So text to image models. So these have the ability to generate image from text. So this is a perfect example of generative models. Okay, this is also true. We are trying to understand everything that's written in that book line by line. Given a test image, the system asks whether it is a cat or dog. Model that has better fits is less surprised by the image, chooses that as a label. That's fine, guys. Whenever you have a discriminant model, it would rather have the goal to understand how cats are made and how dogs are made. And whenever you are giving it at a image at the test time and you want to predict that whether that image is of a dog or a cat, it would be more like it would choose the one by which it is less surprised by. Okay, a discriminant model by contrast is only trying to distinguish the class perhaps without learning about them. Okay, so guys, a discriminant model has the goal to discriminate between two classes without understanding them. Okay, because a discriminant model, all it has to do is perform a particular task. Let's say classification. It doesn't have the capability to generate content. Okay, generate content. It doesn't have the capability to generate content. Okay, let's just try to move ahead. So maybe all the dogs in the training data are wearing collars and the cats aren't. Maybe. If that one feature nearly separates the classes, the model is satisfied. That's true. If you ask such a model what it knows about cats, is all it can say, they don't wear collars. As I said, the main goal is not to understand how a dog dog's image is created or how a cat's image is created, the main goal, what is the main goal, is to just discriminate between the two classes. Now we formally recall the naive bias assigns a class, this is word class to a document D not by directly computing PC of D but by computing likelihood and prior. So guys, see, in my naive bias class I made you sit and gave an example for dear friend. So how did we compute dear friend? What is this argmax, likelihood and prior? So we computed likelihood, probability that dear comes in normal messages, this is likelihood. And what is the prior probability? Prior probability is just the class probability that we were multiplying, right? If you would remember my lecture, I had numbers like 8 by 12 and 4 by 12, so we were essentially just having those numbers also over here just to get the stuff done. And as I told you that okay, we are going to choose the one which has the highest probability, that is just the argmax. Okay, so we have two things, one is the likelihood, okay, we have the likelihood probability and the prior probability. So when we use something like this, okay, it's okay if you can't remember this is okay, but you remember, right? In a naive bias examples you were multiplying probabilities and stuff. So essentially naive bias is a generative model. Okay, this is very important question. This can be asked in an interview to test your fundamental knowledge that whether naive bias is then generative or discriminant model. And there you just need to give them example of this dog and cat and just make them understand that hey, in naive bias we are multiplying likelihood with prior in order to calculate the class, and then we are taking the argmax, that's essentially the highest one. So there in my example I computed a probability of yes and no, right, in spam and ham, and then I took the ones that has highest, so that's essentially argmax. So it's saying a generative model like naive Bayes uses the likelihood term which expresses how to generate features of a document if we knew it was of class C. Yes. And guys, by a discriminant model and text categorization attempts to directly compute PC of D. Okay, this is fine. So guys, main thing that you need to understand is that what is the underlying difference is a discriminant model versus a generative model. Specifically in today's terms, because guys, as I've told you that times have really changed and we are moving really fast, so we need to understand how does it all fit into the situation where LLMs are also used. Not if we are not talking about LLMs, guys, actually then it would be very not so fruitful. The idea is that if we have a model which just distinguishes between the classes, then it is a discriminant model. And essentially when we have a generative model, that is, it understands how the classes are actually created, that's generative. Number two is that a generative model can generate content, guys. Okay, and guys, you can give the example of naive bias, but as I said, now no one uses naive bias. But yeah, so essentially, in order to, they don't compute the probability, they don't compute the probability directly. Rather, they use a mixture of like they multiply likelihood versus and prior, like we did in our example. That is okay. Like it's just a different computation, and here we directly compute probabilities. This is okay, guys. This much is fine. But the main thing is, guys, we are talking in terms of modern day LLMs. So the thing out there with modern day LLMs is that modern day LLMs, how are they? I mean, there would be a lot of lectures coming up, but the main thing is they are generative, first of all. So, guys, that is why it's said generative AI. So, you have models which can generate content. And, guys, essentially, how is it happening at the backend is just giving you a high level overview. In backend is the problem statement here is of this is basically referred to as auto regressive LLMs. Okay, what does this means? This essentially means the problem statement in backend is next token generation. So in simple terms, it's like what is the probability of the next token generation, next word given past words. In simple terms, guys, this is it, right? So it is computing the probability, okay, but it doesn't compute it in the way like discriminant models do. Obviously with overtime you will understand, but understand the main thing is that essentially what happens in the last layer is what happens there is that multiple words are assigned multiple probabilities, and the word with the highest probability, that's essentially, some people like to call it argmax in simple terms, that is selected, okay. So a model essentially is generating next word or tokens, okay. So it's generating the next token, and the main idea is that whenever the next token gets generated, it's not that it just generates a single token, it generates multiple tokens, okay. But the token which has the highest probability is rendered, right? Like once you ask an chat gpt, hi, it says how are you. So first of all, how gets rendered, then r gets rendered, and then u gets rendered. So guys, this is how it works. And r and u are getting rendered because at the time of testing these two are assigned the highest set of probability. So guys, this is an important question. Generative versus discriminant models. I took out some text from some Stanford book as well, just to give you an example, better example. So guys, slowly we are going in deep, and I understand that this would be a long playlist, but guys, as I've said, that only future skill set is AI engineering. So it's good that you are investing times in understanding the basics. Soon I'll be uploading more videos. So please guys, subscribe to my YouTube channel and have a great day ahead. Thanks.